All right. So tonight we are very, very excited to have Brittany Hege here from Mix and Math. Brittany is a math educator. She's worked with students and teachers in both upper elementary and middle grades. She holds a master's degree in elementary mathematics education, and she's passionate about helping teachers grow their understanding of the math concepts that they teach. Brittany believes in the power of experiencing math through hands-on work and uses her platform, Mix and Math, to equip upper elementary teachers with the knowledge and confidence to inspire a generation of empowered math learners. The word I've known Brittany for a short time, but I can tell you the one word, and it's passion. That I you're going to see it tonight, and I'm going to say it's infectious. And so, with that, Brittany, I am going to stop sharing, turn off my camera, and start listening. So now it is all yours.
Awesome. Well, thank you so much. And thank you, just Brainingcamp, for having me and all the teachers who are here. Thank you so much for being here and giving up part of your day to just spend this time with me and talk and learn about math. And, something that Mark said, he said, passion is infectious. And I took this term from my husband because my husband talks about passion being contagious. And truly, that is why I do what I do. And I hope you walk away from this workshop with an aha moment or that light bulb moment that gets you so excited about multiplication. I know I sound like a big nerd saying like, let's get so excited about multiplication, but I truly want you to just have that light bulb moment about multiplication because I truly believe that your excitement, your light bulb moment about it will fuel your teaching whenever it is that you get to a point of working with your students on multiplication. If you haven't already this year, or, obviously we're working on multiplication all throughout the year, especially if you are in upper elementary. So I would love to hear kind of where we are at. I know obviously multiplication, we want to cover this all year long, but if you follow a curriculum, you typically have units and multiplication is in several of those units. Have we already taught multiplication for the year and now we're just kind of like infusing it in everything we're doing? Or is that maybe a unit that is coming up? So let me know in the comments. Also, when I love to do, Tracy said starting next week. So when I do these workshops, I love for them to be really interactive. So definitely make sure that you are commenting, and I'm going to try and pull up the chat. I'll have to just switch screens. That's okay. We've got this. So for those of you who don't know who I am, my name is Brittany Hege. I am the creator of Mix and Math. And one of the reasons that I do what I do is because of my classroom experience. So I remember, and this is related to multiplication, and it really was my light bulb moment that I think drove the content behind this session. Is I remember teaching in 5th grade. I was working with a group of students on multiplying fractions, and I was expected to teach the algorithm for multiplying fractions, but truly I did not have a single memory of ever using the algorithm for multiplying fractions growing up. I'm sure I learned it, but it had been so long since I had had to do any operation with fractions. And so I remember feeling really nervous going into it. And then also, when we started it, it was like students had never worked with fractions before. I felt like I was starting with a blank slate. Does anybody else feel that way? Whenever you get into concepts like maybe operations with fractions and decimals, it feels like you've got to start all over, right? Students are this like empty vessel. And it wasn't until I really got passionate about making math hands-on and I started, challenging myself. I was like, how would I make multiplying fractions hands-on? And as I was exploring this, I had my own aha moments. I was like, oh, that's why the algorithm works. Oh, that's why we do this when we multiply fractions. And it was at that moment that I realized like students have been preparing for this since 3rd grade and even earlier than that. And so often we look at just the standards for our grade level and we forget about all the knowledge that students bring with them from previous grades. And so I love this quote. And I think this is a really great quote to kind of like frame our discussion today. And it is from Peter C. Brown. He is the author of Make It Stick. And he says, all new learning requires a foundation of prior knowledge. The more you can explain about the way your new learning relates to your prior knowledge, the stronger your grasp of the new learning will be and the more connections you can create. And so I think that this is really important for us to start here because in order for us to really learn, we need to be able to build on something else and make connections to something else and relate it to what we already know. And so in my experience with my students, when I would start, multiplying fractions and I wasn't starting from where students were at, the knowledge that they already had, I was kind of doing them a disservice. And so one of my favorite things to talk to teachers about is we should be more curious about what students do know than what they don't know. We want to figure out and be curious about what they know so we can build on that. And that's exactly what this entire session or this entire workshop is really going to be about, is this progression of multiplication from third grade all the way through fifth grade and really beyond that, and how we can make sure that we are connecting each new grade level expectations to what students already know. And also just recognize that our students are not these empty vessels that I thought they were. They are not these blank slates. They come to us with so much knowledge that we can build on, and that actually makes our job a whole lot easier when we are teaching multiplication or we're facilitating learning of multiplication. So if you are somebody who needs to know, like, what is the agenda for tonight, we are going to start off by talking about building operation sense. If you're not familiar with what that is, we'll talk about what operation sense and how we build that. Then we will get into multiplying whole numbers, then multiplying fractions, and multiplying decimals. And often, depending, I know every state is different, and the state requirements are different for standards. But typically we've got those multiplying whole numbers in third, fourth, and fifth grade, multiplying fractions in fourth and fifth, and then multiplying decimals in fifth grade. So if you fall in those age ranges or those grade ranges, you will get a lot out of tonight. And if you fall right outside there, this is the foundation that our students should be coming to us with. And if they aren't, this is the foundation that we really want to build. So give me a thumbs up in the comments if you are ready to get started. So this right here, this chart, this is it's actually from a progressions document, but really these are the multiplication and division problem types that came from the work of the authors of CGI. And really this is just saying, so we have this operation of multiplication, and multiplication behaves in different ways. And so we can have a situation where multiplication can be represented or talked about as equal groups, right? So I have 3 bags and I have 4 apples in each of those bags. That is that equal groups, behavior of multiplication. And then we also have arrays, which are, I have 4 rows of apples, and there are 5 apples in each row. This also, depending on some documents that you see, you'll see it broken out as area as well. But often when we're talking about arrays, we really use a lot of that equal groups language. Like we have 4 rows and we have 5 apples in each row. That's very similar to that equal groups discussion. And then we also have multiplication as a comparison. And so that is when you get into that like multiplicative comparison. So I have 4 apples and my friend has 5 times as many apples as I have. That's that comparison. Where we are really going to sit tonight is we are going to be talking about context and situations where multiplication is equal groups. So just wanted to kind of like frame that discussion for us. We're really going to be talking about it as equal groups, but there are other ways that we can experience multiplication. But I find that this equal groups experience that students have starting really early is really helpful as we look at the progression of multiplication across grades. So let's talk a little bit about operation sense. So I love this quote from Mathematize It. It talks about how students with operation sense can mathematize a situation and translate a contextual understanding into a variety of other mathematical representations. So that sounds like very wordy. Let's talk about what that means. We want students to have operation sense because it's very similar to number sense, but it's like with operations. And it just means that they can experience something in life and they can mathematize it. So they can take this situation and they can turn it into into a mathematical representation so that they can solve whatever or problem solve whatever that situation is. So it's I've got a first grader. So it's my first grader going into a store and recognizing that he has $10, but the thing he wants is $12. How much money does he need to ask me for to buy this toy? That is mathematizing. It's taking that context and translating it into mathematical representations. Now, if you're curious, like what those mathematical representations are, you may have seen this if you've attended another Brainingcamp webinar, or even if you've attended a Mix and Math webinar, you've probably seen this model here. Let me know in the comments if you have seen this. It's called the Lesch translation model. These are the 5 modes of representation. You can also let me know in the comments if this is brand new to you. And so these are just the 5 different representations, 5 different ways that we can represent math. We've got the physical, which is your math manipulatives, visual, which are your number lines, your area model, which you'll see a lot tonight. Any drawings that students are making of their mathematical ideas, that's visual, are symbolic. That's how, if you ask a random person on the street, what is math, they're probably going to give you a symbolic representation. They're going to be like, oh, it's 4 times 3, or it's the division algorithm. Contextual, which we'll talk quite a bit about tonight, is that word problem, but there's also other there are also other examples of contextual, which, like I said, we will talk about here in just a bit. And then verbal is us talking about math. It is the language. It is anything that is written about math. This is all verbal. So I think it's really important for us to see that all of these are important. There's not one that's more important than another. Oftentimes we have students, especially if we are working with students in upper elementary, who feel like maybe they're doing something wrong or they're not as smart because they use math manipulatives. And I think it's really important for us to just set the norm that this is how we do math. We use all 5 of these representations. Neither of them are better or worse than the other. They really bring our understanding together. And as we start to look at this progression, all of these representations are necessary to deepen students' understanding of multiplication. And I just wanted to show you this. I actually took this picture. This was my work when I was sitting in a session at a conference and we were playing with the math. And the only way that I could make sense of the math was to have all of these representations. And it was there that I was like, oh, that's what that means. So even us as adults, I think it's good for our students to see us experiencing or using all of the representations as well. So let's start out. We are actually going to be using the Brainingcamp live mode tonight. So we're going to start by exploring multiplication with whole numbers. And so I am actually going to open this up and I'm going to start a live session. So if you have not used Brainingcamp Live, it is fantastic. So let me click live here. The share code, this is just taking me to a like a screen, a board, a workspace. I'm not sure exactly what you call it, that I have already created. And so now I'm clicking live here and you should see a code right here. If you want to engage in this activity with us, go ahead and put this code in and you should, oh, I already see somebody in there. You can see right on the side. All right, I see 2. I think that, let me double check. I think, yep, Jeff has got the code in the comments for you. Awesome. So let's go ahead and get started. So we're going to look at this very first problem here. And it is you have 6 boxes of cookies and there are 4 cookies in each box. Now, something that is incredibly important for us to make sure that students understand is that the fact that in a multiplication problem, so let me write this, this would be 6 times 4. Each of the factors have 2 different jobs. One of these factors is called the multiplier. And this language actually came from, not necessarily the multiplier, that's pretty common language. This factor right here is the multiplier. It tells us the number of groups. So we've got 6 boxes or 6 groups of cookies. But this word right here, this came from actually the authors of Manipulatives. They call it the measure factor. And that is how many are in each of those groups. And it may seem silly to put an emphasis on this multiplier factor and this measure factor, but this is incredibly important when we get into multiplying larger numbers, when we get into multiplying fractions and decimals. We want to know what these numbers represent. This is also why context is so important. We want to know what these numbers represent, and we want to know what the jobs of each of the factors are. So here we've got 6 groups of 4. So go ahead, use your unit cubes to model your 6 groups of 4 here. Whoops. All right. And I am just going to copy these right here. All right, so I've got my 6 groups of 4. Now, a lot of times teachers will say, well, would it have been correct or incorrect if a student modeled 4 groups of 6? And if we didn't have the context, then yes, it totally would have been correct. But here, when we want students modeling the context, it needs to be 6 groups of 4. Here, our representation matches the context. So we've got our 2 factors, we've got the job of them. Now, this is typically like a 3rd grade standard, right? Students are developing their understanding of multiplication and their multiplication facts. But this is where it gets so exciting, because when we are really teaching multiplication for understanding, and we are not just having students memorize facts, we're not just having them memorize what 6 times 4 is, but we are developing their fluency. We're helping them develop those strategies for figuring out the product of these different multiplication facts. One of those strategies is often add one more group, right? So we often know our 5 facts are really comfortable to a lot of students. So we know that 5 boxes of 4 cookies is 20. And then if we have one more box, that is 4. And together, that's 24. So that's how if you're a 3rd grade teacher, if you are working with students and developing their fluency with multiplication facts, like this is one of the strategies that we want them to use, to be able to add a group, to take away a group, to think about 6 times 4 flexibly. Now, this is where it gets so exciting, because this thinking right here is the foundation. It is like the beginnings of that partial products thinking that we want students to be using when they get into multiplying multi-digit numbers. And so here, I'm actually going to slide this activity over just a bit, because we're going to come back to this, and we're actually going to see how the work that students do with this problem, as simple as 6 times 4, it builds towards students being able to solve this problem of 16 times 4. Now, what I want you to do is I want you to think about, how could you figure out the number of cookies of 16 times 4? Now, if you are not there, go ahead and slide over. I want to see your work. I'm going to put it up on or highlight it. So go ahead and start thinking about, how could you figure out 16 times 4? I'll give you just a second to go ahead and model that on your own. And while you do that, I'm actually going to do a couple models as well. Okay, so I see some people choosing to use cubes, which is the first thing that I did here. I see let's see. I want to make sure. I think if I open this, I don't think I lose my work. Okay, there we go. I see this teacher's work of breaking it apart. I love that. So this is one of the really fun features about Brainingcamp Live. I love that I get to see students work as they're doing it. Okay, so let's look at this. 16 times 4. How could you figure this out? So some students who are maybe a little bit earlier in their understanding of multiplication might actually model out 16 groups of 4. Others might see this strategy that we did here of being able to decompose it and think about it as, well, if I could do 5 groups of 4 and one more group of 4, could I do, and this is exactly what this teacher right here did, could I instead think about this as, 10 groups of 4 and 6 groups of 4. This is the same type of thinking, just applied to larger numbers. And this is really the foundation that we are using. This is the type of thinking that we are using when we expose students to the area model. And so I'm going to draw this. It's going to be a little bit messy, so forgive me. But when we are having students represent their thinking with the area model, we'll think of, okay, we've got 10 groups of 4 here, and that is 40. And then we've got 6 groups of 4, which is 24. And so here you see these connections. And one of the things that I really wanted to point out is, how do we get students from this place to this place? And there's actually 2 ways that we can do this. Oftentimes when students are just developing their understanding of multiplication and they are developing that fact fluency, we don't often use the area model with students. Some of you may, your standards may call for it, but typically in the 3rd grade classrooms that I'm working in, I'm not seeing a lot of use of the area model. But that does not mean that just because they're not using it in 3rd grade, that when we are starting multiplication in 4th grade, that we can't say, hey, remember how you were using this strategy? There's a really great model that we can use, and you're going to see this a lot this year, that can represent that thinking. And we can go back to the facts that they're comfortable with and introduce them to the area model. And we say, here, you see what you did? You did 5 groups of, whoops, that's not where I want to put that. Well, you did 5 groups of 4, and that was 20. And then you also added 1 more group of 4, and that was 4. And what did you do to figure out how many there were in total? There was 24. Okay, well, we see that 24 here. So now we're exposing them to a new representation that models their thinking. And then we can use this representation and say, okay, how could you use this representation with this problem right here with 16 times 4? They can still use the cubes if they're comfortable with it, but now we're making that connection. We're taking this model and we're connecting it between 2 different problems. And here we're taking this problem and we're connecting it with 2 different representations. One of the things that I didn't talk about when I showed you that less translation model is these connections are so important. If we go back to that very first quote that I read to you about building on that prior understanding, that last part of it is the connections are what helps students retain what they are learning. It is what helps them really internalize what they're learning. And so we want to make these connections. We have the same problem, 2 different models. Here we have the same model with 2 different problems. Okay, does this make sense? Do we see? Oh, go ahead.
Hi. Hey, Brittany, it's Mark. Sorry to interrupt. Yellow is hard to see. Can you maybe choose another color for the annotations?
Yes, absolutely. Thank you so much for that.
Awesome. Thank you.
So is this making sense? Let me know in the comments. Do you see how the work that we're doing in 3rd grade is really building towards students thinking about partial products in 4th grade? And then we move over to this last problem here when we're talking about multiplying whole numbers. Now, I want you to think about how you could figure out this problem. This is going to be one of your, depending on what state you're in, your standards, your 4th or 5th grade problem. Here we have all the same context. The context here is really just to give students that visual to latch onto. So when we're talking about breaking apart these factors, we're thinking about, okay, well, I have this number of boxes and how many cookies are in that number of boxes. And then we've got this number of boxes left. How many cookies are there? So take time to figure out how you would figure out how many cookies are in 216 boxes of cookies. So I see some work. Y'all are doing great. I love seeing your representations. While you were doing some work, I'm going to kind of take a peek. Okay, so I'm seeing lots of area models. Here's another one with an area model. Yep, I love it. Obviously, yellow is very popular because lots of us have chosen yellow tonight. Okay, so I'm seeing lots of area models. And this is, I think, actually really important when we talk about, there's a progression within multiplication, but I also find there's a progression in representations as well. Some of our representations or the models that we use are going to come earlier in students' journey, right? We would not likely use cubes to figure out how many cookies are in 216 boxes of cookies. Instead, we're likely going to move to a representation that is probably a little bit more abstract, a little bit more like advanced than having to actually model each individual cookie. And so a lot of us are using the area model, and it's really taking that same thinking. Let me move this over real quick so I can get to a different color for y'all. There we go, black, much better choice. Is we would likely use an area model for this. And students can decompose this in any way that's comfortable to them. This last problem that we had over here, students didn't have to decompose this into 10 groups of 4 and 6 groups of 4. They could have done 5 groups of 4 and 5 groups of 4 and 6 groups of 4. We want students to have that flexibility. But as students get or have more experience, they start to see that decomposing by place value is typically the most efficient. And so here we could figure this out by first finding 200 box, how many cookies are in 200 boxes. And the number of cookies that are in 200 boxes is 800 cookies. And then how many cookies are in 10 boxes? Well, 10 groups of 4 is 40. And then how many cookies are in 6 boxes of cookies? And that's going to be 24. And we could go through. You'll have to excuse my writing. We can add these up and figure out that the answer is 864 cookies. So do we see how all of this builds and progresses to when students come to you in 5th grade, they are not empty vessels. They're not starting all over. Everything that they've been doing in previous grades has helped them think about the fact that we can decompose this in different ways. Now, one of the things that I want us to be mindful of, and I was actually talking to the guys at Make Math Moments about this, is a lot of times we see the area model as a really powerful tool, but we proceduralize it. And so we tell students, okay, we're going to take this box, and if it's a 3-digit number, we're going to break it down into 3 sections and put lines here, and then you're going to multiply here by this. When we do that, we're not really getting at the understanding that we want students to have. We're not getting at why we can break it down and find 200 groups of 4 and then 10 groups of 4 and 6 groups of 4. That is why the context is really important, and building on what students already know is so key here. So now what I want us to do is, a lot of this may feel really familiar to us. We've worked with multiplying. We know how to make multiplying whole numbers hands-on. We've seen the area model. But how does this build towards some of the really tricky concepts like multiplying fractions and multiplying decimals? And so what we're going to do is we are actually going to, let me move on over to this one. We're going to start with fractions. And some of you may think, well, why would we go to fractions next instead of decimals? And I actually was going to share this on the decimals one, but decimals are actually much more abstract than fractions. We'll talk about that a little bit later, but really multiplying fractions builds beautifully into multiplying decimals. So what I want us to do, you can exit out of that live. We're going to create a new live session. And I hinted at this a little bit at the beginning. Let me exit out of these. I want to make sure that I don't slow my computer down. But I mentioned this at the beginning. I said that I always root for the underdog, and that pattern blocks are one of my favorite math manipulatives. We are going to explore multiplying fractions with pattern blocks. Let me know in the comments if that is brand new to you, or if you are a pro at using pattern blocks, you know exactly how to make multiplying fractions hands-on using pattern blocks. All right, I see some new, never used it. Awesome, love that. Okay, you are gonna walk away with some new learning tonight, so that is great. So let me see. Oh, I didn't push. Oh, there we go. Now I'm in the live. Did we get that live code in the comments? Let's see. Let
Hey,
me
Brittany,
make sure.
could you just show folks where to enter that live code, or one of us can?
Yes. Is it right where we put the share code as well?
Yes. Yeah.
Okay, perfect. Yep. Let me show you real quick. So I guess I can go back here. I'm going to show you exactly where to put that code. So when you click share code up here, so when you're logged into Brainingcamp, right at the top, you can put that share code, and that will take you directly into the live experience. Mark, let me know if I explained that correctly. Hopefully I did, but I see lots of people here.
Perfect.
Okay, wonderful.
Perfect. Thank you.
Okay, so Let's talk about multiplying fractions. And it's key that we connect it back to the work that we did with multiplying whole numbers. But before we do that, I want to give us kind of like a crash course on using pattern blocks for fractions. So here on the side, you can see I did a little key here. If the hexagon is the whole, which the hexagon does not always have to be a whole, but for this webinar, we're going to keep the hexagon a whole. If the hexagon is a whole, I want you to go ahead and type in what you think the trapezoid would represent. So how does the trapezoid relate to the whole? And I can already see some of you are going in and filling that out. Oh, whoops. Maybe you're not filling that out because I must have locked this. Hold on. I guess in the live mode, I can't unlock it. That's okay. That was my fault in how I set this up, but we will just go ahead and we will write it here. The trapezoid is half, because it takes two halves or two trapezoids to be equivalent to that whole. And here we've got the rhombus. The rhombus, if we were to actually put this here, you would see my terrible drawing skills. You would see that the rhombus is 1/3 because it takes three of these to be equivalent to the hexagon. Here we've got this right here is the quadrilateral. This is going to be 1/4. And if you were doing this with students, if they were exploring this for the first time, y'all, I did not get a degree in art. That is for sure. If students were doing this for the first time, we would not be just telling them, hey, this is 1/4. They would actually be playing with the manipulatives to figure out, okay, what is the value of this, this quadrilateral? How does it relate back to the whole? And this is 1/4. And because I don't want to spend our entire time just going over the value of these, this one right here is 1/6 because it takes 6 of these triangles to be equivalent to a whole. So now that you have this, I want you to model this very first problem. You have 3 bags of flour and there are 6 pounds of flour in each bag. How many pounds of flour do you have? Now, as you can see, this is really going back to the very first problem that we did last time. But we are connecting, we are using the manipulatives, and we are connecting to what students already know. We need to start students from a place of confidence. They need to recognize, okay, I know how to solve this problem. I can model this problem. So while you are doing this at the same time, I'm going to go ahead and model this. And if you are not copying and pasting, you're missing out, because this will save us so much time anytime you are using Brainingcamp, is to use that copy and paste feature. So we have 3 bags of flour. There are 6 in each. And so I've got 6 holes right here, and we've got 3 bags. How many do we have? So students can write an equation. They can figure out that we've got 3 times 6 equals 18. And you may say, okay, but what does this have to do with fractions? We are just starting them from a place of confidence. You know how to do this, right? Now let's look at this problem. You have the understanding, you've got the tools. How could we take this same problem and actually model this with fractions? What would it look like to model? You have 3 bags of flour, but there are 2.5 pounds of flour in each bag. So I want you to take what you know about the pattern blocks, and I want you to model 3 bags of flour with 2.5 pounds of flour in each bag. What would that look like for the second problem? I'm going to give you some time to actually model this out. I already see some of you starting. That is fantastic. So often we think that we have to tell students how to do this, but it's so empowering when they see, okay, I can do this. I've got the knowledge and I've got tools. And from there, what we are going to do is we are going to pull out the math from this. We're going to pull out, we're not going to start with an algorithm. We're not going to start with a written strategy. We're going to let them use the tools that they have available to them and see what they can do with it. And so I already see so many of you. I'm going to go ahead and highlight this one right here. Here we can see viewer 15. I wish there were names on here. You actually can set names, I believe, but viewer 15 is already starting to model those groups of 2.5. So we've got 2 and 1/2, and this is 1 bag. And now we've got another bag. Let's talk about the importance of context here, because if we were to just give students, this problem right here is 3 times 2 and 1/2. If we were to just give students this problem, how many of us think that our students would be able to model this? Like if we weren't really giving them that context, it feels a little abstract, or they might think, well, we haven't learned how to multiply fractions. When we give them the tools, they can do it. And what also, going back to what we talked about at the beginning of this workshop, we talked about how important it is for students to understand the multiplier, the factor, and the measure factor. Like, what are the jobs of the factors here? This is why it's really important, because when we look at, and when we have context, it's not as important because the context does it for us. But when we are using kind of like just a naked problem here, 3 times 2.5, students need to recognize that 3 is telling us the number of groups, and 2.5 is the amount in each group. And something to be really mindful of is when we get into 4th grade, depending on your standards, it may be a little bit different. We are typically having students multiply whole numbers and fractions. But it's in situations where the whole number or where the multiplier is a whole number, because you are going to see in a second when the multiplier is a fraction, that's a very different type of thinking. This right here, though, when the multiplier right here, this number is a whole number, it builds beautifully on what students already know about multiplication, right? It's equal groups. We have 3 equal groups, and there are 2.5 in each of these groups. So looking at your work, it looks like we're really good. We fully understand how to use pattern blocks to multiply fractions. Here we can see, okay, what's the value? Well, we have 3 groups of 2. Now we're getting into that partial product thinking here. We've got 3 groups of 2 is 6. And then here we've got 3 groups of 1/2. 3 groups of 1/2 is 3 halves, or 1 and 1/2. And together that gives us 7 and 1/2. And this thinking is so much more long lasting, because when we think about when we go out to a restaurant and we tip, or if we're thinking about a percentage of something, oftentimes we are thinking about this as like, what is, if we're wanting to tip, let's say you're wanting to tip 25%, then you're thinking, okay, what's 20% of this and what's 5% of this? We're decomposing, or we're finding those partial products here. That's exactly what students are doing here. And you would be amazed. I had 5th grade students who could solve these complex multiplying fraction problems in their head because they had this thinking. They had this understanding. They didn't have to think about, okay, I need to turn it into a fraction greater than 1, and then multiply the numerators, multiply the denominators. We've got this level of thinking. And so what does this look like? What's kind of like the next phase in the progression then? I'm going to ask you real quick. Let me know in the comments. Are you with me? Do we get... let's see, do we understand the connection, or what's building on, here we're building in 3rd grade, multiplying whole numbers. Do we see how multiplying fractions just builds beautifully onto that? It's really that next step. Awesome. I love it. Gloria said, yes, we are doing good. Great. So we're going to take it a step further now. Now let's talk about what happens when the multiplier, so the number of groups, is a fraction. And I would really, really encourage you to look at your standards and really make sure that figure out where this falls in your standards. Because a lot of times we think that this is 4th grade, but in a lot of states, it's actually 5th grade when we are dealing with the multiplier being a fraction and we're scaling that amount. So here, same exact context, a full bag of flour holds 6 pounds of flour in it. Okay, but we only have 1/3 of a bag of flour left. How many pounds of flour do you have? I'm going to do something that's super awkward on a webinar, and I'm going to give you some serious think time. It's awkward for me because I have to sit here in silence and give you time to think, but I really want you to figure out, how would you use pattern blocks to model this? Actually, you know what? You don't have to use pattern blocks if you don't want. If you want to draw a picture, I want you to figure out how you could model, how you could represent 1/3 of a bag of flour. If 6 pounds is the full bag, what would 1/3 look like? And this is really good for us as educators, as teachers. We have to play with the math and think about the math ourselves so that we know how to support students. And when students get stuck, we can kind of like pull a representation out of our back pocket and say, hey, have you tried this? Or let's work on it in this way and see what you think. So I'm going to give you some time. You can tell I'm just talking to fill the silence, but I want to give you time to really think about this. What would it look like to find 1/3 of 6? 1/3 times 6. Ooh, I love this. Okay. I still see some people working, but for the sake of time, oh my goodness, I see so much great work. Y'all are awesome. I'm just gonna show several of these. All right, here we can see this person modeled the 6 pounds of flour and broke it into thirds and found 2. Another representation of this. Let's see. Y'all are awesome. Thank you so much for participating and working. Another one, 6, found 1/3. Okay, so this brings meaning to exactly what, I'm actually not even going to remodel it because y'all did such a great work here. I'm just going to show this one again. So here we have 6 pounds of flour and we have 1/3 of a bag. So what is the value of 1/3 of 6? And here we can see 1/3 of 6 is 2 wholes. Now, what if I said that we had 2/3 of a bag of flour left? What would that be? Well, now looking at this model, we can find 2/3. And 2/3, let me color. I don't know if I can actually write. Well, we're going to test this out. I'm not sure if I can write on somebody else's work here. Oh, wonderful. Here we've got.
And then you can click the blue push button in the top right, and then that person will get that feedback.
Oh, wonderful. Okay. Well, I'm not going to send this back to you, viewer 1, because I'm sure you're not happy that I'm writing on your work, but I did want to show you if we were to find what 2/3 is, now we have 4. And again, I want to connect this to the real life. When we are in, I keep going back to tipping. This is exactly the work that we're doing. Oftentimes, if I want to figure out 20%, what do? I take the total value and I split it into 10 equal groups and I find what's 1/10. And then from there, okay, but I want 20%, so I need 2 of those groups. That's exactly what we did here. To find 2/3, we find 1/3, and then find 2 of those groups. We need 2 groups of 1/3, and each of those thirds is worth 2. So this model just makes sense. It brings meaning to this is so much more fruitful work than teaching students, okay, we've got 1/3 here, and then the algorithm is going to be, we're going to multiply by 6 and then put the 1 here. And then we've got 6/3, which is 2. So hopefully this is making sense. I'll go ahead and push this back to you. I apologize, viewer 1, for writing on your work, but hopefully this is making sense about how all of this builds. And this is a little bit different when we're talking about the multiplier being a fraction. It is a big jump for students beyond the multiplier being a whole number, but here's what we did. We got students really comfortable with a representation that they can now use when they're trying to make sense of an experience that feels really different. Having multiplication scaling a number and we're getting a product that is less than the original factors, that is different. Students often think multiplication makes things bigger, and that's not always the case. And so the reason students are able to make sense of this problem is because we've built their representational competence. Representational competence just means that they are like fluent in using representations. We've built that representational competence so that they can approach a new problem and use those models to make sense of it. So this is really kind of that progression of multiplication with fractions. And then any other problem that students do work with when it comes to fractions is really a combination of this multiplier as a whole number and then the multiplier being a fraction, which is scaling. So if you think about like 3.5 groups of 6.5, we can still do that same thing of 3 groups of 6.5 and half of 6.5. Like once students have the understanding of both of these, they can really attack any problem. Now, I will say this. Not every problem is going to be model friendly, right? Like not every problem is going to be clean and we're going to be able to use manipulatives, and that is okay. The reason we use manipulatives is to build the understanding that they can then apply when we get to situations where where it's not a model-friendly number. We can't use manipulatives, but they have the understanding that they need. And so I love this quote from Julie Dixon. She says, "We reach for proficiency, but we fall back on what makes sense." So we want students to have a way to solve problems, any problem, even if it's not model friendly. But at the end of the day, students will always fall back on what makes sense. And when we go into teaching multiplying fractions and we are just teaching that algorithm, they don't have anything to fall back on. They don't have that thing that makes sense. This makes sense. And I know we're flying through this and we are obviously just looking at one problem for this, but this is a progression across 3 grades here, right? We've got 3rd grade here, this is 4th grade, and this is 5th grade. So students have time to make sense of this. So what we're going to do as we finish out, because I know that it's we're already getting close to time, is let's take a look at decimals really, really quick. So I'm going to make this live, go ahead and exit out, and then not exit out of the webinar, but just exit out of your workspace that you're working on. Here is the code for multiplying decimals. We will just look at a few, maybe just like 1 or 2 of these, but go ahead, enter the code. I see some of you are already jumping in. And you will get a replay of this afterwards. I believe it'll get uploaded onto the site. So if you need to rewatch this, that might be really helpful because I know we're going kind of fast. But I did want to take a look at the progression for multiplying decimals and how it builds on what students already know about multiplication from previous years. So if you're not familiar with using base 10 blocks for multiplying decimals, typically we use the flat as a whole. Again, that doesn't always have to be the case because our pattern blocks and our base 10 blocks are unlabeled. We can change the value of the whole to whatever we want. But because base 10 blocks and pattern blocks are all about relationships, when we make the flat a whole, that makes the rod 1/10. Because, and actually I'm going to write it in 2 ways. I'm going to write it as a fraction and as a decimal here. This is a great tool if you teach the standard of building connections between fractions and decimals. This is a great tool to use because students can, layer these rods here on the flat and see that it takes 10 of them to be equivalent to a whole. And here we've got 1/100th, and written as a fraction, we've got 1/100th. All right, so let's take a look at this very first problem. And if you are not there yet, you can go ahead and start modeling it. But in the science lab, you need to add 1/1200 liters of water into each of the 6 test tubes. Even if students have not learned how to multiply decimals yet, this is the exact same work. If we were to change this value, rather than 1/1200 liters into each of 6 test tubes, if we were to say 12 liters into each of 6 test tubes, students can model that. And so I'm going to go ahead and model this. We've got 1/10 and 2/100ths. And again, don't forget to use that copy and paste tool. It'll make your life so much easier. And here we've got our 6 test tubes and we've got 1/1200ths in each one. And so how do we figure out what's the total value? And even as students are going to move this around to rework it, to figure out, okay, what is the value of all of this? We go back to that partial products thinking, right? Well, here I've got 6/10ths, and I've got 6 groups of 200ths. And so I'm going to rework this just a little bit here. And you'll probably get the picture here. We've got 6 groups of 1/10 is 6/10ths. And we could model this. Oh, that was the other thing that I forgot to show you on the last one. When we were working with multiplying, that's okay. It actually would have been really helpful. The area model is something we can use with fractions as well. We won't have time to go back and do it, but just know that the area model would have been a really powerful tool. And I had it in my notes for us to go over and I forgot, but that's okay. But here, same thing. We're taking this, we can combine them. And this is the same work that we would use when it's the same thinking, it's the same work that we use when we are representing this with an area model. So I'll take this, and I've got 6 groups of 1/10, which I've got modeled right here. And that's 6/10. And then I've got 6 groups of 2/100, which I've got right here. And that is 6 groups of 2/100, 12/100. And then what is the total value here? We add these up and we've got 72/100. So all of this, when we really think about multiplying decimals, all of this is just applying what students already know about whole numbers, about partial product thinking, about the representations they've used, the area model, using base 10 blocks, and applying it to a different situation. So when we give students the representations, we give them the tools that they need, they can do such great things, things that are far beyond what we think that they can do when we aren't supporting them with the variety of representations and helping them see the connections to what they've already learned. And so here, we're not going to go through this because we don't quite have time, but here I want you to see this problem if you want to work through it on your own. This is an example of that. Remember when we talked about the big jump of moving from the multiplier factor being a whole number to the multiplier now being a number less than 1? So it is scaling. That's what this is. So here we would have to figure out what is 1/10 of 3. So later on your own time, think about how you could model 1/10 of 3. Again, it's such great work for us to spend time working through these math concepts so that we know how to support our students and facilitate experiences for them. And then here, this one is a combination of this. It's that multiplier being a whole number and the multiplier being a number less than 1. We've got 2 and 1/10. So what's 2 groups of 3 and then 1/10 of 3. And all of this, every single thing that we worked through today can be represented using an area model because that thinking is so important for students. So I know that we just flew through this. I'm going to go back to this final slide. We are going to recap and I'm going to pass it over to Mark. But when we think about just kind of summarizing what we learned today or what we talked about, I want you to remember to be curious about what students know. Figure out what it is, where they're coming from, what knowledge they bring with them, and then build on that. Start with what students know, let them start from a place of confidence and kind of refresh their memory of their knowledge and the representations they can use to explore concepts for the current grade level, the work that you're doing. Always relate back to the meaning of multiplication and the jobs of the factors. These are not just 2 completely random numbers. They have meanings. One of them is the multiplier, especially when we're talking about multiplication as equal groups, and the other is the amount in each group. I would encourage you to emphasize the connections and create bridges between problems and models. So often we were using either the same model with a new problem, or we even using the same context with different numbers to advance students' understanding of the math. So anytime we can make connections between different representations or different problems, that is going to move them along that progression in a way that makes sense to them and allows us to build on what they know. And then this is something that we actually didn't get to talk about too much, but I want this to be kind of something that you just take with you and just kind of consider this. Anytime students are using a representation, whether that is an algorithm, whether that is manipulatives, we want to make sure that the representation is of their thinking. So if they are doing an algorithm and that's not actually the thinking that's happening in their brain, we've missed the mark. If students are using an area model and the area model is proceduralized and it's not really representing their thinking about how they're decomposing these situations, then we've missed the mark. We want to make sure that anything that students are doing is a reflection of their thinking. And so that is all that I have for you today. I say all that. You may have felt like you were drinking from a fire hose here, but I hope that you have, and I would love to know in the comments, let me know in the comments, what your number one takeaway is from today. I think it's really important for us. We can sit here, we can hear an hour's worth of content, but let's think about that one thing that we're going to go into our classroom and apply. You don't have to implement everything you learned today. It can be just one small tweak that could make a really huge difference. But like I said, that is all I have. You can follow me. I am just Mix and Math in all the places on Instagram, Facebook, my website, and obviously make sure you have your free trial for Brainingcamp, because none of what I just showed you would have been possible without the Brainingcamp live features. So hopefully I did Brainingcamp justice.